My name is Sumit Maheshwari. People sometimes call me Sumit. Uh, yeah, but that's fine. I'm a tech lead at Uber's data platform group and also a PMC of Apache Airflow. Today, I'm going to talk about the operational Airlift, which is basically Uber's ongoing journey to migrate to Airflow 3 from their in-house system called Piper. So there's a slight correction. Yesterday, Vikram mentioned in the keynote that Uber has been migrated to Airflow 3, but that is slightly true because we are migrating and not yet done. It might gonna take a year from here. So yeah, let's see what Airlift is. Anybody remember this thing? And I'm not here to sabotage Airflow with the promoting some competition. So yeah, this is something which I saw roughly around 6 months in my LinkedIn feed, and it's kind of a competitor of Airflow is trying to say Airlift is moving out of Airflow, and we are looking for a name for the project we are doing. And I thought, like, why moving out of Airflow? Airlift should be something which is moving towards Airflow, right? So yeah, that is how we um look the project, which is basically Airflow. A big pine wheel is basically powering up the big fat, uh, you know, lifting the Uber's airplane into the air. Yeah, so this is the rough agenda. We're gonna see the history, like what is Piper, how it got evolved, and then we're gonna see what are the challenges we are facing day to day with the Piper, and then the plan to move or migrate to Airflow. Why Airflow? We're gonna see it here, and how we are actually implementing it, and what is the adaptation and migration will look like over the year, over the next year, and finally the conclusion, right? So yeah, let's look back at the history of the Piper. So some of you who have attended the last year summit might remember our talk me and my colleague gave in SFO last year. We actually take in detail about how Piper, which is basically a fork of Airflow 1.x, I think it was 1.10, in 2017, and how it got modified over the years, and to achieve a scale of running 200,000 pipelines or DEGs from a single production cluster, and how we are able to clock roughly 800K task instances per day. We are running a salary fleet of roughly 1,000 plus machines, and almost more than 1,000 teams, uses our tooling to do the day-to-day orchestration requirement within Uber. There's a YouTube video link for the previous year talk. Yeah, but I will be covering a very high-level things that what makes Piper it is. So the journey started around 2017, where they forked it from the Airflow and hit some potential roadblocks or issues, and then they migrated. The first one was they defined the serialization format and defined into JSON, and then the scheduler was divided and converted into 4 different services. So the first is we call it organizer, which is very similar to the DEC processor in current Airflow world, which basically serializes all the DEGs or pipelines into JSON. And then there are other services, say orchestrator, which is basically assign the different pipelines to different scheduler nodes, so that we have the truly HA, and our HA is basis on the Zookeeper and the scheduler nodes, and not on the MySQL row logs. Then the scheduler, which is basically more or less, you can say, copy of the Airflow scheduler, but rewritten in Java. And the last is the prioritizer, which basically pushes up the task the scheduler generates into the queue. Queue is basically the Redis queue. Why Java and not Python? There is no specific reason for that. It's just that I think in that time, Uber was not really wished to invest into different languages, basically, and Python and Go and Java was the majorly supported languages. It could have been done into Python as well. Yeah. And then we got this UI-driven backfills, which we have in Airflow 3, but we have it back in 19 as well, where you just go into the UI and specify what is the start date, what is the end date of a particular pipeline. It will create a database entry behind the scene, and the scheduler will take care of launching the task and pipeline runs basically. And the last, and not last, like the another one is basically the secret management. I'm not very much sure if Airflow got the secret managers in 2019. But how Uber did it is basically you define a connection into UI, but the username and password will be coming from a secret manager. So it's like giving the best of the both worlds, basically, right? You in Airflow secret managers, you can't see that connections names in UI, or if you define in the UI, the connections will not be coming from the secret manager. But it's like kind of mix of both the things. Yeah, and the continuation, then we invested very heavily into disaster recovery management around 21. I will be talking more detail in the later slide. Then we got a drag and drop interface, which we called UWork, which will give a easy way to users to create the DAGs from the UI. Then we started using the read replicas for the load distribution from the primary MySQL node. I think that a lot of people who run MySQL for Airflow have faced this thing, some way, sometime, definitely, right? That the MySQL, the what do you call the logs and things like that started getting degraded as soon as more QPM or connections actually get increased. So how we solve is that we moved all the read traffic to read replica, a fleet of read replicas. Basically, it's not a single read replica, a fleet of read replica which are actually scattered around the different region and zones. And now we have roughly 80% of our traffic goes to the read replica and 20% goes to the primary node. And yeah, it's much more stable state than it used to be a couple of years back. Then the next is jump start, which is basically data aware scheduling. You define a pipeline and you say, it will run when this condition met, and the condition is basically a DSL, where you say, okay, this data is older than say 1 hour or something like that. Then the pipeline get triggered automatically, and it will refresh the data sets. Next is the various frameworks, like using that YAML we have, we explain in next some more further slides. Basically, we call it like one ETL and other frameworks are there. You define some YAML syntax and it will generate the pipelines out of it. Next is full-fledged workflow governance. This is very important topic because the governance here is dividing your pipelines into different tiers. And we have like tier 1 to 5, tier 1 and 2 called high tier, and then 3, 4, 5 is called low tier. So when a pipeline get originated, it will be tier 4 pipeline. And then it depends upon what data set it is reading and writing to. And if the data sets, which is writing to, it's like the tier 1 or tier 2 data set, our system automatically moves this pipeline to high tier pipelines. And then when you go to high tier, you got extra SLA guarantees, and then things like that. Whenever there's a disaster happens, you're gonna get resources when the resources are under crunch, basically. So if you're a high tier pipeline, you're gonna get more benefit out of it, right? Yeah, it's like more system level guarantees. Hybrid strategies. We recently last year moved to on cloud as well. So we are like running our system into both on-prem and on cloud, and then we have primary and secondary DCs as well. So it's like permutation combination is happening there. And recently we added this GenAI based task failure summary and mitigation step. So last month we did a talk on this topic in Bangalore Airflow meetup group. The video is out yesterday only. So I would highly recommend, go and check this out. It's like pretty interesting things, some of our team members done there. So yeah, I think those looks good, right? Everything is rosy, right? Then why we need to, change, right? What's the problem with that, right? So these are the major pain points. I can talk. There could be more, but these are the high level ones. That we are actually lagging behind in the modernization. There are no tasks or identities. Basically, all the task flows from the same Celery machines, and like they will treat it as the data originated from the piper rather than that originally is who is the author of them. It's difficult to contain if somebody is doing wrong. And the underlying downstream system does not identify who is the owner of those if something goes bad, especially if something goes bad, right? Slow version upgrade is more like adding the features which are out there, and we had a very tough time adding those features into Piper. For example, last year we added the deferrable operators, and it took almost a year to develop and roll it out because of the size of the system as well, and as well as the criticalities of the pipelines. Efficiency, we have the duplicate pipelines. It means that you cannot trigger a scheduled pipeline, or you cannot schedule a triggered pipeline in Piper world. So people had to, or forcefully, they need to create two pipelines, and it creates a lot of issues. Basically, if you change one pipeline, you have to, and you forget to change the other pipeline, yeah, you are doomed, right? No dynamic pipelines. So again, this is you had to kind of write a new pipelines, which can have been done easily with that if you had the dynamic pipelines notions in the system. And we have data-driven scheduling, but we really miss the event-driven scheduling, right? We do not have the concept of assets and triggering the DEGs on the basis of assets. Reliability, salary plus Redis combo, I will call it like maybe a deadly combo for us. It has been giving us issues all these years. Like sometimes salary does not pick a job, or sometimes it run it twice, and it's almost impossible to figure it out what happened. And it supports only single Redis node. It means you cannot have a Redis cluster working with it, and that means you're gonna get a single point of failure if something goes wrong there, right? And that's gonna give us like sleepless nights. Noisy neighbor, again the salary problem more or less. We are running 8 tasks a node, and one node is hogging up all the CPU and memory. Then the other 7 tasks will actually perish. Safe deployment is more like a Uber concept, which basically it means that if something goes wrong, I want to go back to the previous version. So it's like related to the DEG versioning and rolling back, and something goes wrong in an automated way. Last is their velocity. The Piper do not have a very good local dev story. So people has to either push their DEGs to something called user staging, which is a pre-prod environment, or production. We do not have proper REST APIs. There are bunch of APIs which are scattered around the system, and but there is no unified way to write these APIs or use these APIs. And of course, outdated SDK authoring, because if you look at the syntax, it is more look like Airflow 1.x syntax. Let's go ahead, right? Why Apache Airflow and why not something else? This is the question we got, within Uber itself, maybe 1,000 times, right? Why Airflow and not something else? And our answer would be very similar to this, right? Airflow is one of the most popular system. It is battle tested at a lot of big companies, and Uber itself is one of them. It has very active community. We have lots of connectors, and it is supported by almost all the major cloud vendors out there. One strong point I see is that the DSL of Airflow is very similar to Piper, because Piper is born out of it, right? So our user base, our users will not see a totally new tool, or they don't have to invest into learning the new syntax. Like if I have to use X, Y, Z rather than Airflow, then they have to invest some cycles in learning that tool, which is not the case. And known unknowns, basically there has been issues when Uber initially tried to use Airflow and then eventually eventually converted to the Piper. But we know that what are the issues we faced earlier, and we know that how we solved those issues earlier, right? So if those issues kind of reappeared again, we know how to solve them. Yes, just that last time we took a different strategy of forking it and doing it. This time we have different strategy to not to do that, so not end up in the same situation again like Piper 2. Right. And the last is the Airflow 3. I think if it is a very important, the features of Airflow 3 is the crucial in deciding us to take the leap. Things like isolated workers, modern UIs, and fast API-based APIs, the DEG versioning, and then task in any language. These are some very crucial features. I think without those features, it won't be possible for us to, even persuade anybody to move to Airflow. Yeah. So this is a kind of a eye-to-eye comparison of Piper and Airflow. You're gonna see lots of raids in Piper and some raids in Airflow as well. But there are some features which are like very crucial. For example, like the dynamic DEGs, the KTS executors and operators, which we don't have in Airflow, which we don't have in Piper, and would have to reinvent the wheel if you wanted to use them. And then DEG versioning, event-driven scheduling, I think non-Pythonic task and open source community. These are the major things I would say. Of course, Airflow 3 does not have the things, something which Piper has. For example, disaster recovery, drag and drop UI, governance frameworks. So that is what we are planning to say, convergence, right? How we gonna bring those things which are missing in Airflow, but which are required to make it work at Uber. To start with, that Piper's, the backfill, we can use the Airflow's native backfill, which got released in Airflow 3. We have YAML-based frameworks, like dozens of it. So we are planning to use something called DEG Factory, which is I think Astronomer open source library. It's not part of Airflow, but part of the ecosystem. So we are, thinking of using that to replace our own frameworks. Data hour scheduling, Jumpstart, we can use the Airflow event-driven scheduling, and I think it's a much more superset of what we have already. So I don't see any issues in that one. And lastly is that the drag and drop UI, we call it UWork. We need to kind of make it work with the Airflow as maybe like a new engine in the UWork basically. There are still some challenges I can see right now. That the DEG processor is still running in control plane. It means that the users who are writing their DEGs can actually connect to that metadata DB if they want to. There's a safeguards in place, but those safeguards can be broken if somebody wants to, right? And that is why this AIP 92 is on OpenAIP. Maybe we'll implement some days in future, so maybe in a couple of months later. That is making all the services like DEG processor and triggerer, and maybe something else like callback processor to move to the client side or execution side of it rather than the control plane side. The second is all Airflow services connect to the same database in read-write mode. And we have raised in AIP 94, but right now it is not approved. So it's moved back to that pending AIP state right now. Maybe over the time when we are able to migrate and able to see that, okay, it's hampering, the MySQL, we have to revive this AIP again and get it done. The third is basically that Airflow's in-house inbuilt scheduler HA, which works on the row level locking in MySQL world. We use MySQL, right? So it will gonna use the row level locking to distribute the DEGs and create the task instances. But we have seen issues when you're running, like say 100K or 200K DEGs. This might not going to scale, and then we have to revive it, and we have to maybe propose a solution which is more like Piper's base, where basically the scheduler gets the zookeeper and don't take any row level lock in MySQL. Disaster recovery, we have to rewrite. I think there is no way, there is no shortcut there. And some construct like rollback and incremental rollouts, that is also missing from Airflow, but at least the DEG versioning is kind of a building block, and we can build on this DEG versioning to achieve something called, say, auto rollbacks or the incremental rollouts as well. If auto rollbacks is basically you release a DEG to production and it got failed, or it got a metric which emitted alert, or maybe a data set which failed into the quality checks. In that case, there is an automated event which would actually roll back the particular DEG. And of course, we do not want to roll back all the 200K DEGs, maybe that particular DEG or a set of DEGs. So yeah, those things we have to build on. Going next, we'll talk about like implementation details, some high-level implementation details, not everything, of course. So before going that, I just wanted to give a very high-level overview of Piper so that you are able to correlate the things. we actually presented this particular diagram last year as well. So if you look at last year's talk, you're gonna see it. But yeah, so the starting point is basically that users are writing their DAGs into a UI framework or via Python or via APIs, and then we have a service to serialize those DAGs. Then we have different services in Java, which is basically distributing this DAGs to different scheduler nodes, which is emitting the task instances, and the prioritizer is basically pushing those task instances to the Redis. And then we have the fleet of salary worker, which basically consuming those task jobs from the Redis, and then eventually calling the underlying services, right? And last year we did not have the triggerer part, which we added here. So now either it's salary or trigger, which basically talking to underlying services. So this is something, this is a proposed Airflow high-level, design we are having, and it is like got multiple revisions basically, but this is what we are going ahead with now. We basically, if you look at this bottom thing, basically we have forked the Airflow repo, but we are keeping it close to the open source one, so that we are able to upgrade in future easily. So all our development is happening via plugin based route or providers based approach. Then our services, which we will manage, will be running into a SaaS infrastructure, which we get out of the box from within Uber, from the compute platform, and our scheduler, API servers, and triggers will be running there. And the secrets and runtime configurations belongs to our services, not the user's DAG. And the users are supposed to write their DAGs into this monorepo. And this monorepo the code of this monorepo is kind of changing very frequently. Like you will get roughly 100 to 200 commits a day. So we need a way to deliver it fast. So that is why we are actually doing a git sync at the host level, to the Kubernetes infrastructure, and that those will be get mounted to the DAG processor, and as well as the task pods which are running there, so that it won't take too much time. Once your change is there, it will be get immediately available, maybe within a couple of minutes, and the DAG processor will able to serialize it and able to update it to the API server, and also your task pod will be able to launch it, and then the task pods will be able to writing into the logs, and those will be get pushed to a centralized logging mechanism we have within Uber. I told you that this is the fourth or fifth iteration of the design. Earlier we wanted to go ahead with a per DAG image basis, where every DAG change gets rebuild a new image, and that's gonna give you a revision ID, and you can easily roll back. But the issues with that, Kubernetes internal caching won't work if you have too many DAGs, right? It will not scale basically. And there are some other solutions as well, like we wanted to go ahead with the PV based one or a NFS one, but those were not supported at the moment. So that's why we are going ahead with the git sync. Maybe in future will be a small change here and there. I just want to deep dive on this API server part. It is not what is the native Airflow's API server, and we actually kind of put a wrapper around it. We created a wrapper service around the Airflow's API server, and the main reason is that we did not like the Airflow's RBAC, which is coming out of the box, right? It's very difficult to manage, and I think most of the time it does not make very much sense. Like, why should I can have access to DAG or things like that, right? So so what happens is basically users comes and it requests some resources. Let's say I want to view the DAGs, or I want to say pause or trigger a DAG, right? If I want to view the DAG, viewing is kind of allowed within Uber, right? So everybody has the view access if you are logging. That's it, right? So basically it will talk to this identity service, verify the user is logged in or not, and if he wanted to do some action like a pause a DAG or a trigger a DAG, then we're going to see if it's part of the owner group or not. If they're part of the owner group, yeah, good, you can go ahead, and we're gonna bypass basically and do a kind of reverse proxy to the Airflow API server and get the request done. Also, there is a way to expand your access to the different teams and different users. So this charter service or RBAC service is very simple, work on very simple promises, right? Which is basically who is the actor, what is the who is the actor, what is the resource, and what are the actions, right? Very simple thing, but it's a centralized service which will be used by almost, I don't know, like 5,000 different microservices within Uber. So yeah, it's like it worked at a very huge scale. But yeah, like, and also we have lots of other APIs to support going forward. Like for example, the disaster recovery API, there are alerts API, there are deck creation API, and so on and so forth, right? So we don't want to add anything into Airflow's API server, and that is why we created this wrapper around it, so that yeah. And yeah, this is another important piece. How the disaster recovery work in Piper at the moment is that you have a primary region and you have a secondary region. Primary region is basically you are running all the pipelines there, and we have two types of pipelines. One is called the single region compute, and there's something called dual region compute. So SRC ones basically runs in the primary, and the dual runs into both the regions. Then dual region, the second region has the less capacity to run the Piper resources, less capacity to run the Presto, less capacity to run the Spark. It is kind of reserved for tier 1 and tier 2 pipelines or workloads only, because when something happens, we want that our tier 1 and tier 2 workloads get the priority and get the resources in the secondary region. So if you look at the left section, it's like a Piper HLTI earlier showed, right? And the right section is also similar, but we got a multi-region database, which is basically is like a glue, which will be like joining these two different data centers in a way. Because when a scheduled pipelines, say we move this pipeline from primary to secondary, it needs to know that, okay, how much work has been done already. It cannot start from the beginning, right? Otherwise, it will be create more incidents than solving anything. Yeah. So this multi-region database is basically is kind of glue. Though there are lots of challenges, basically we have to kind of keeping these three databases like this 1, 2, and 3 in a sync, which is not a MySQL sync, right? It is more of a conditional sync. Basically, I want to do this pipeline is single region compute, and now it gets changed to dual compute, and like there are so many permutation combinations, right? So we are bombarded by the complexity of this thing. So we are kind of proposing a much more simpler DR for Airflow, where we are saying that, okay, will not deal with the DRs within different regions and things like that, and we'll kind of say the primary and secondary will become as a part of the resources of Airflow service itself. And it's kind of a multi-regional setup basically. So even if the resources are running in primary and that can be taken away eventually, right? Maybe then that is possibility, right? In that case, our things or our Airflow UI or the Airflow workers and scheduler should be able to run it from the secondary as well. Of course, we're gonna pause all the tier 3 plus pipelines, so that only tier 1 and tier 2 pipelines or DEGs will be scheduled in that secondary one. Because this is the source of the workloads, right? Like it's actually spawning the Presto jobs, Spark jobs, and Hoodie jobs, another type of job, right? So if we contain the inflow of tier 3 and plus pipelines from here, everything will be actually like the tier 1 and tier 2 pipelines going forward. Yeah, and I think next section is about the migration. So we have, at high level, we have 4 type of pipelines. SDK ones, which are basically the Pythonic nature, and their syntax is similar to Airflow 1.x. Users write them into their ID or and then commit into a Git repo. The managed ones are basically the API ones or the UI ones. Users goes to a UI and just drag and drop and save it or deploy it. It will get stored into JSON as a database. Stored into DB as JSON. Then we have backfill pipelines, which is basically nothing but associated with a parent pipeline. And you go to UI, say I want to run this pipeline from X date to Y date. This is my parallelism, and this is something I want to override if there is, and then that's done, right? And then last is the framework pipelines. You go and write into YAML, and done. You just commit, and then you're gonna give a pipeline out of it. So I think this is one of the most difficult section here, like converting the SDK pipelines because it's a Python code, and and there are, in the first slide I mentioned we have 50K Python files in the system. And going to the users and saying that, hey, please change your pipelines to Airflow compatible code is very difficult, right? We're not gonna get good feedback or good support. So what we're trying to do is that we created a tool which basically reads the Piper pipeline, parses it into that using the Python AST parser, and we have the mappings data with basically, I'll just show example, right? We have the mapping data which tells how to convert this Piper pipeline into Airflow DAG, and then it actually emit Airflow DAG. And we actually expose this thing as a utility called Piper Dev, which is basically internal tool to deploy and manage, things. Um, uh, yeah, and basically you can convert a single pipeline, or you can give a whole folder, and it will just emit. It will just walk through, and it will just convert. Yeah, right. So this is what it looks like. Yeah. So that mappings of the YAML file you saw earlier, right? This is where basically this rules are defined. Like for example, Piper.models import pipelines will get converted into Airflow.models import DAG. Similarly, for configurations and things, for example, Piper.task.dummy task doesn't exist in Airflow, of course. So it's called empty operator. So that we're gonna change it, and then if you look at here, line 21, it will get converted from pipeline construct to DAG construct. And there are some options which actually does not make sense in Airflow world. Used to make sense in Piper world. For example, like owner LDAP group or secure or something like that, data center choice mode. So that will get omitted. Otherwise, it will gonna fail. And lastly, we had something called set upstream and set downstream syntax that get converted into this fish type of syntax. Of course, this is the most easy example. It maybe get more complicated, but yeah, that's a start. That is how we are planning to convert it. And we have a centralized tool called Shepherd, which basically can run this thing, and then can raise the diff and can take the relevant people who are actually supposed to be author of those pipelines. Yeah, conversion of the managed pipelines or the API pipelines would be little simpler because we control how to generate the DAG at the runtime. So we just need to kind of added a new flag called execution engine is equal to Airflow, which is right now does not exist, but it can be Piper or Airflow, and then our driver can just emit a Piper pipeline or Airflow DAG depending upon that flag. And yeah, we just have to make sure that we do it behind the scene without impacting the users. So users maybe from the U work, they really don't care whether the pipeline is running in Piper or in Airflow, as long as it does what it's supposed to do, right? Like move the data or run some ML jobs. Yeah. And yeah, this is something like a Vanitil framework, which is basically a YAML-based framework. So it has a entry folder where you go and basically define your configs and write your jobs. And then this is an example pipeline where it just you just have to tell that what is the DDL file, what is the SQL file, what is the high table, what is the staging schema look like, or what is the name of that thing. We just added another option called execution engine, similar to previous slide, Airflow Piper, and it will convert your DAGs or pipelines, sorry, Piper pipelines to Airflow DAGs behind the scene, and you should not be like really worry about it. Yeah. Yeah, I think so. Towards the last slides. So this is the end goal of our whole migration to Airflow 3, right? That the journey will start either to a UWork, or which is basically UI, or IDE. You write, AI assisted code development. Basically, you're gonna write a Python code, or you're gonna write, you're gonna generate a JSON definition using the UWork, or maybe you're gonna write a YAML definition for one of the frameworks, right? And the next step would be the interactive development, where you will be either testing your changes into a notebook environment or a dev pod. Dev pod is basically a single Kubernetes pod given to you for your interactive development. Then we have the dry run environment. If you don't want to do interactive, then you can go the dry run environment, which is basically pre-prod setup. Call it user staging. Your DEG will deploy it there. It will run end to end. Complete DEG will run basically, and then you decide if you want to really do it or not. The code review, we have actually a lot of AI assisted code review as well. Once your code review is generated, you're gonna get review from your team members as well as our AI. Finally, the linters, of course, will part of the CI/CD, and eventually you merge the code. After you merge the code, there is something called safe deployments, which is a kind of an opt-in thing for your DEX, right? So if you say that, okay, I want the safe deployment to be enabled, and that will be enabled by default for tier 1 and tier 2 pipelines, right? What does it mean? That you have to define some set of rules. For example, my DEX get fail after deployment, or this particular data set doesn't pass the data quality check, or this particular metric get emitted or not get emitted, or something like that, right? So you define those set of rules, and what will happen that our system will monitor, and if any of this thing actually happens, we're going to roll back that deployment, and that is where the DEG versioning is really required for us, because without the DEG versioning, this thing won't be possible. Right? And the lastly is observability, where we basically have the logging of the Airflow task logs, as well as we have lots of metrics get emitted, and you're gonna get the alert out of those matrices. And last is basically the governance. Governance is basically like a reactive thing. Your pipeline goes live, it is touching some data sets. So our governance, you can call it pipelines or crons, which is gonna monitor what tiering it should be, or whether if your pipeline is failing for 10 times in the last 10 runs, then it is not a right pipeline. It will actually want to pause it. Or if your pipeline is going to expire, then it will actually send you alert and eventually expire or pause that pipeline as well. So all those things will, is a part of this asset governance. This is it's very large image, not able to fit it here, but this is our rough timeline. Basically, we have done with the POC, and now we are doing the beta. So in the beta, we are actually building the system. And once the beta is released by this year end, we actually going to involve other teams and users to onboard to Airflow. And by the next half, it will be GA. It means we're going to end of life for the Piper. It's not going to be allowed to create any new pipeline into Piper. And in the last phase, in the next half of the next year, it's going to be migration phase, where basically we migrate all those 4 type of pipelines to the Airflow. And I hope that is a long plan. And lastly, I am actually big Bollywood fan, and when I chose this name Airlift, there's something I realized. There was a movie named Airlift in 2016. It was a very really good movie, and I hope that once we're done with that whole thing, we're not gonna leave the chaos behind. Maybe a flower bed behind. So that's our hope. I think that's it from my side.